Hello class, welcome to Geometry, Lesson 1-8, which is all about indirect proofs. After this lesson, you should be able to use indirect reasoning in order to write a proof. Before we get started on this lesson, I want to do a quick shout out to Lizzie. She just stopped by to say hi right before I started recording. Alright, example 1, use indirect reasoning. Okay, so let's talk through this situation and figure out how to use indirect reasoning. Indirect reasoning is going to sound the name itself sounds a little scarier than what it actually is. You guys naturally already do this kind of thinking. Okay, so Beth is having dinner with Sarah and one of Sarah's friends, Libby, Kelly, or Mercedes. Beth orders a chicken and spinach pizza to share for dinner. Who is having dinner with Beth? Okay, and then it gives us 3 pictures and descriptions of Libby, Kelly, and Mercedes, and information about each of them. Okay, so if we look on the left-hand side, Libby, it says, is a vegetarian. Okay, so if Beth ordered a chicken and spinach pizza to share for dinner, would Libby be someone that's present? No, because she's a vegetarian. She's not going to eat the chicken. Okay, let's look next. We have Mercedes. Mercedes is at the library. So if she's at the library, does that mean is she able to be at dinner? No. So we're going to cross Mercedes off the list. Kelly is allergic to mushrooms. Okay. So is Kelly able to eat a chicken and spinach pizza? Yes. So you'd say Kelly is having dinner with Beth. So that's all it is, just kind of using that process of elimination. So I want you to use indirect reasoning on this first question. A bagel shop gives customers a free bagel on their birthday. Theda went to the bagel shop today, but did not get a free bagel. What can you conclude? Hopefully you concluded that it is not Theda's birthday, and that's why he didn't get a free bagel. All right, now take a screenshot of this because this is going to be something really important. Writing an indirect proof by contradiction. So a proof that uses indirect reasoning, what we were just doing, is an indirect proof. And in order to write an indirect proof, you only want to do that when a direct proof is possible. So meaning if there are so many correct answers that you can't possibly go through and prove that each correct answer is correct, you use indirect proof instead. And there are 2 different types of indirect proofs. One is proof by contradiction, and the other is proof by contrapositive. So first we're going to talk about proof by contradiction. And a proof by contradiction, the really, really important stuff, is right here. So when you write your proofs, I do ask that you actually write out step 1, like the words, literally write step 1, and then fill in whatever information you have. I will ask you to write step 2, and I will ask you to write step 3. Okay? So proof by contradiction. Suppose we have a conditional. If P, then Q. Our first step in writing this proof is that we assume that the original statement P is true, and we assume that the negation of Q is true. Okay, so I'll show you exactly what that looks like with an example in just a minute. Step 2 is that you show that if you assume that the negation of Q ends up causing a contradiction or leading to something that isn't true, that's what goes in step 2. Sometimes it's calculations, sometimes it's definitions, so it's just words. It depends on the situation. Step 3, you conclude that statement Q must be true. Okay, so let's talk through what this might look like. So example 2, write an indirect proof by contradiction. So we want to write an indirect proof of the following statement using a proof by contradiction, and our conditional, sorry, forgot the word. Our conditional is if Alani walks more than 8 kilometers over a 2-day period, then she walks more than 4 kilometers on one or both days. So our step 1, write out step 1. And remember, this is where you assume that if P, then not Q is true. Okay, so I'm going to say assume. So I'm going to assume Alani walks more than 8 kilometers in 2 days. That's my P statement, right? So I keep that just like it is. So assume Alani walks more than 8 kilometers in 2 days, and she walks less than 4 kilometers on one or both days. The reason I switched it to less than was because I needed to negate that more than. The opposite of more than would be less than. Okay, so that's my first step. I kept the P statement the same, and I changed the Q statement. Step 2, I want to show, using some calculations, that that can't be true. Step 2. Actually, I'll do step 2 in another color. So step 2. All right, so let's look at the Q statement. She walks less than 4 kilometers on one or both days. So less than 4 means that 4 is not included. So I could say like 3.9, and I could say 3.5. Those would both be less than 8 kilometers for the 2 days. And if I did that, I would end up with 7.4. Even if I did 3.9 plus 3.9, I'd end up at 7.8. And both of those numbers, it doesn't matter what 2 numbers you plug in, you're never going to get to more than 8 kilometers. So you can see that these 2 items are both less than 8. And I can actually write that a little nicer for you guys. I can say 7.4 is less than 8, 7.8 less than 8. All of those numbers are going to be less than 8. You can write this out with variables to be a little more specific. I'm more focused on you guys learning how to do the different steps than getting super complicated in those calculations. Okay, so then step 3. I've done some calculations to prove in step 2. So step 3, this is where I kind of write a couple of sentences to show that the assumption led to a contradiction, hence contradiction, proof by contradiction. So our original statement must be true. So in step 3, I wrote, since our assumption in step 1 led to a contradiction of the hypothesis, the original statement must be true. All of your proof by contradictions, I'm okay with them ending with some sort of form of that. If you want to be a little more specific and include details from the specific problem, that's fine. But I'm okay with this just being kind of an introductory proof by contradiction, indirect proof, okay? You can do a generic step 3. Since our assumption in step 1 led to a contradiction of the hypothesis, the original statement must be true. And that contradiction of the hypothesis, you might be a little confused by what that means, but that's what we did in step 2. We showed that the step 2, those calculations, they didn't hold the hypothesis true. They weren't more than 8 kilometers, okay? I want you to try to write an indirect proof by contradiction. Remember your step 1, 2, and 3. And try to write it down on your paper and then pause your video. And once you've written it down, check your answer, okay? Hopefully you ended up with something that looks like this. Step 1, you made an assumption that you draw an angle that's greater than 90 degrees and it is not obtuse. Step 2, you can say, well, by definition, an obtuse angle is greater than 90 degrees, okay? So that means in step 3, you can just say, since our assumption in step 1 led to a contradiction, meaning it contradicted the very definition of obtuse, so since it led to a contradiction of the hypothesis, the original statement must be true. All right, indirect proof by contrapositive, same idea, but just slightly different. So we talked about contrapositives back in, I believe it was 1.5. So remember, we talked about all of those different, if P then Q was our conditional, if Q then P was our converse, if not P then not Q was our inverse, and our contrapositive was if not Q then not P. Okay, remember that's our contrapositive. All right, so just a little background there. So step 1. Assume that not Q is true. Step 2, show that the assumption leads to not P, which shows that if not Q, then not P. So then you're able to conclude that if P, then Q must be true. Now, if you remember, going back to the conditionals and the contrapositives, those two things always had the same truth value. So that is why, if you're able to prove if not Q, then not P, that proves if Q, then P, because they have the same exact truth value. All right, so now let's talk through the indirect proof by contrapositive. So our indirect proof by contrapositive, remember, we're still going to do those 3 different steps. And our first step, remember, is to show if not Q, or assume not Q. So let's start by just identifying the P statement and the Q statement. So P, for 2 positive integers n and m, if nm is greater than 16, so that's going to be my P statement. So my not P statement would be nm is, instead of greater than, I'm going to say less than 16, but I'm also going to include that or equal to, so that way the number 16 is included somewhere. For my Q statement, then either n or m is greater than 4, or both are greater than 4. So Q would be n is greater than 4, or m is greater than 4, or both are greater than 4. So my not Q would be n is less than or equal to 4. And so instead of using the word or, I'm going to use and m is less than or equal to 4. Okay? Meaning they both have to be less than 4. That is the opposite of what was stated previously. So step 1. Assume not Q is true. So we are assuming that n is less than or equal to 4 and m is less than or equal to 4. Step 2. Okay, so if I know that I have n is less than or equal to 4, and I have m is less than or equal to 4. Now remember, I'm trying to show that step 2 gets me, I can somehow manipulate this step and get to my not P. So I want somehow to get it to look just like that. Okay, so if I am trying to get these 2 inequalities to look like that not P statement, if I look, the left side of the not P inequality is nm. So how can I change this first inequality here to have an nm on the left-hand side? I'm going to multiply by an m. So I'm going to multiply by m on the left side. That means I also have to multiply by m on the right side. Because as long as you multiply by the same amount on each side, you're okay. Now if I look at this right-hand inequality, and I want that to look like the right-hand side of my not P inequality, I have to get a 16. So what do I have to multiply both sides by in order to get a 16 in one of those places? I have to multiply by a 4. So if I say 4 times m is less than 4 times 4, which gives me 16 on that right-hand side. So now if I look at these, I could say nm is less than or equal to 4m. And then look, 4m repeats. So I can just say 4m is less than or equal to 16. But the not P statement doesn't have that 4m anywhere. So what I can do is get rid of it. So if I erase it, I erase that 4m. I have two inequalities now facing the same exact way, so I'm just going to erase one of them. And if I look, ooh, that did not move like I thought it would. I can move that nm over. So I just used algebra to kind of manipulate those two inequalities in order to get them to match that not P statement. And since I was able to get it to match the not P statement, that means I was able to get it back in the form if not Q, then not P. And since I was able to get it back in that form, my step 3, I am ready for now. So I can say step 3. I can say something like, since step 2 gave us the contrapositive, we can conclude that the original statement must be true also. Okay? We can conclude that the original statement must be true also. All right. Now, I want you guys to try, just like you did with the proof by contradiction, try this proof by contrapositive on your own, and then compare your answers to mine. Good luck. Hopefully your step 1 looked similar. You assume tomorrow is not Thursday. Step 2, if tomorrow is not Thursday, so I started with that not Q statement. So just thinking about that. If tomorrow is not Thursday, then today cannot be Wednesday. And that right there, just thinking about that, if tomorrow is not Thursday, then I'm thinking to myself, well, then today can't be Wednesday. That right there actually gave me the contrapositive. That is the contrapositive, which means I am ready to move on to step 3, which is since the contrapositive is true, the original statement must also be true. Okay, I know these are going to take some practice and maybe be a little frustrating for you guys, but remember, I'm here to help. And if you have questions, please remember to ask either myself or a friend. And I hope you guys have a great night.